Hello everyone. Today we'll be discussing a problem that was asked in IITJAM Physics question paper 2009. The question is from Classical Mechanics, which focuses on rotational motion. Firstly, let's read the question. A thin massless rod of length 2L has equal point masses m attached at its ends. The rod is rotating about an axis passing through its center and making an angle theta. The magnitude of the rate of change of its angular momentum is. So in order to understand the question, let's analyze its diagram. We have two masses placed at two ends of a rod which is of length 2L. So we have the length as 2L. So this is the axis, and the question says that the rod rotates along its axis with an angular velocity omega. So here we have the length as L and the other end as L. As it is rotating, we have something like this, right? Wherein here is our axis, making an angle theta. So here we have the length as L, and this is going to be our perpendicular distance r, and this rotates along its axis with an angular velocity omega. So we have been asked to calculate the magnitude of change in angular momentum with respect to time. Now let's get into the solution part. We know that angular momentum L can be given as mvr, as our objective is to calculate the magnitude of change in angular momentum with respect to time, which is nothing but dl by dt. We can differentiate this equation, this particular equation, L equal to mvr with respect to t, which becomes dl by dt is equal to d by dt of mvr. We know that v can be written as omega into r. So here becomes d by dt of m omega r square. Now on differentiation we get 2m omega r and dr. So now let's get back to the diagram. So here's our diagram. We have an angle theta and the length L with a perpendicular distance r. From the above diagram, we can thereby write r by L is equal to sine theta, and from here we can write r equal to L sine theta. Now we have r. So as we have differentiated this equation, we have dl by dt as 2m omega r dr. So we have r. So with r we'll find dr. Sorry, this is going to be dr by dt. We can write it as dr by dt is equal to L is a constant, cos theta, and as we differentiate theta with respect to time, we have the equation dl by dt as 2m omega r into r dot. R dot is nothing but differentiation of r with respect to time t. Now we can substitute r and dr by dt in the given equation, wherein we can get 2m omega into L sine theta into L cos theta into d theta by dt. d theta by dt can be written as omega, which is nothing but angular velocity. So from here we can write 2m omega L squared. So we are going to get omega square, because d theta by dt is omega, and omega into omega we are going to get omega square, sine theta cos theta. But still the problem is not complete. Let's examine this particular equation. We might have seen this 2 sine theta cos theta as sine 2 theta. So therefore dl by dt is equal to m omega square L squared into sine 2 theta.